Hi, everyone, and I'm just going to get us started off today, talking about chapter one out of our Frost and Deal book. Today, this video is going to be on section 1.1, which is on classifying matter. Right, so let's get into the material. This is a fairly short section, and we should be able to get through this one fairly quickly. So, section 1.1 is on classifying matter. Now, first thing we need to talk about is what is matter? Okay. Well, I'm going to give you two definitions for this. First of them is more of a nuts and bolts chemistry definition. The second is just kind of a practical one. So, to get to the nuts and bolts definition, basically matter has two properties. One of them is that it has mass. Has what has one S, has mass. Now, what does that mean? What is mass? That gets into kind of a circular definition because mass is a measure of the amount of matter that is present. But anyway, we say that it has mass. And the second property that matter has is that it has volume. Or another way to phrase that is we could say that it takes up space. Now, kind of our more practical definition that we can use is that we could just say that matter is stuff. Okay? Simple, straight to the point word, but anything around us that we touch, see, feel, smell, what have you, is matter. Right. But we're scientists. We like to classify things, and it serves us a purpose. And so we can split matter up a couple of different ways. First thing that we're going to do is we are going to separate matter into two different categories. We are going to talk about pure substances and we are going to talk about mixtures. All right, a pure substance. Pure substance basically just means that if I have something, it is composed of entirely one element or one compound. All right. Now, what does that mean? That's two different. Let's talk about elements first. Elements are things that we find on the periodic table. That's a little bit more of a section 1.2 topic, but just some common elements that you might find around you: oxygen, nitrogen, things like that. We could also talk about one. So when I talk about pure substances, one of the examples I always like to give is copper wire. Copper wire is 99.99% copper, right? Copper metal, elemental copper. And so, yeah, copper is a great example of an element, but it's also a pure substance, okay? Now, when we talk about pure substances, we can also talk about compounds. Okay, compounds are, and there again, this is straying a little bit into section 1.2, but compounds are two or more different elements that are chemically bonded together. I'm not going to write that definition down just yet, but that is a compound, right? Now, really common compound that you all may be familiar with, H2O. Okay, now, H2O, of course, is water. Now, when we talk about, if we talk about water being a pure substance, that means water that has nothing else in it. So if we go and we buy distilled water, or if you're in the lab and you use deionized water, basically those two are kind of sort of the same thing. The names are just descriptions of how we get to pure water. They get there by different ways, but the end result's effectively the same. But distilled water, there's nothing in it but H2O, nothing in it but molecules, each of which contains 2 hydrogens and 1 oxygen, chemically bonded together. So that is a compound, right? Those are both pure substances, though, right? Now, when we talk about, we can then talk about mixtures, right? What is a mixture? Mixture is 2 or more different substances. Now, what's a substance in this context? That means either an element or a compound. 2 or more different substances physically combined together, right? 2 or more different substances physically combined together. So really common one, really good example of a mixture that we could make is I can take salt, table salt, sodium chloride, NaCl, and I can dissolve it in water. When I do that, I get a mixture that I call salt water. Put enough in there, I call it brine. I put enough salt in it, I call it brine. But that is a really common mixture. Okay. Most of the things that you encounter on a day-to-day basis are mixtures of some form or fashion. Now, when we talk about a mixture, though, we can further classify that 2 different ways. We can have homogeneous mixtures, and we can have heterogeneous mixtures. Now, one thing I'm going to pause to do really quick here. We're going to learn a lot of words in this course. Several years ago, someone in the for the Journal of Chemical Education looked at the average new vocabulary learned in a freshman or a first year level chemistry class and compared it to the typical new vocabulary learned in a first year foreign language class. And they found that in a chemistry class, or really just in general in most science classes, that you learn more new vocabulary than you do in a language class, in a first year language class. So we're going to learn a lot of words this semester. A lot of new vocabulary. Chemistry is a language in and of itself. But sometimes we can make some sense of the words if we just take some time and break them down. Prefixes and suffixes on things are a big deal. Now, we look at these 2 words. This one has the prefix of homo. Prefix of homo means same. Okay. Prefix of hetero means different. A homogeneous mixture is something that when we combine the things together, we cannot distinguish them from each other. Okay. So what do I mean by that? All right. I'm going to pull my wedding ring off. Okay, my wedding ring is made of 14 karat gold, right? 14 karat gold. Now, what does that mean? Okay, 14 karat gold is a mixture, is a homogeneous mixture, and it consists of 58.5% gold, and then the rest is typically silver. and copper. Now, what ratios on those depends. That's a whole subject in and of itself. But anyway, this is a mixture of gold, silver, and copper. Now, when you look at this, what does it look like? It just looks like it's gold. Okay, you don't see individual chunks of gold, silver, or copper in it. It all looks the same. This is a solid homogeneous mixture. It's the same sort of thing if I look at tap water, right? Tap water, that's a very common mixture that's around us, right? Tap water, of course, mostly is H2O, but it contains a lot of things like a lot of dissolved minerals, calcium, magnesium. Water treatment plants typically add fluoride ions for your teeth. Also, there's chlorine or some chlorine compounds to keep it safe to drink. All the things like that. Lots and lots of stuff in tap water. But if you look at it, you pour a glass of tap water, hopefully you're going to look at it and it's going to look clear. You're not going to see things floating around in it. You're not going to see really anything in it. It just looks like water, even though there are things in it. That is a homogeneous mixture. All right. Another one for us too. Air. Right? The air around us is mostly nitrogen. It's around 80% nitrogen. It's around 16% oxygen. And then we have some other gases in it. Carbon dioxide. Argon's a big one. Not a big one, but it's there. Water vapor actually is a really big one. This time of year, I'm making this video on June the 6th of 2023. So in the summer, especially around here, it gets humid. That means that there's a lot of water in the air. But nonetheless, though, air is a mixture of all these different gases. But typically, at least we hope that when we look through air, we don't see individual things floating around. Now, I know you may look out in your house and you may see dust or you may see things like that. But ideally, air is going to be, we're just going to look through it and we're kind of going to see nothing. Air is a homogeneous mixture. All right. Now, let's talk about heterogeneous mixtures. These are things where we can typically see individual components, right? If we were to look at just, for example, a solid homogeneous mixture, one really good example that we have of that is going to be concrete. Typically, concrete has cement and then it has some sand and gravel mixed in with it. And if you look at concrete, you'll see all of those individual pieces. Concrete, or maybe we could say blacktop, something like that. All those kind of things. You look at them, they don't look nice and uniform. They visibly have different things in them. Going back to that, sand. Sand is a heterogeneous mixture. You'll see different sized rocks, pebbles, things like that in it. Okay, it's a solid homogeneous mixture. We can talk about liquid homogeneous mixtures also. Sometimes we'll call those suspensions. Really good kind of go-to one, though, is blood. Okay, you have blood, you let it sit, it's going to separate out. You're going to get the plasma, you're going to get all of your red blood cells and everything else that settle to the bottom. Okay. A lot of times when we look at a heterogeneous liquid mixture, it will look cloudy, right? Or we won't really be able to see through it that easily. So that's kind of one of our ways that we distinguish that. But anyway, that's a homogeneous and a heterogeneous mixture. All right, that's essentially what we cover in section 1.1. So we will cut this one off there.